In this video we are going to see how we can remote debug a Lambda function, running on AWS. For that, we are going to use the SLAppForge Node.js Debugger toolkit. Let's implement a simple Node.js Lambda function on our local machine. This function will read a name from the name field of the event, and then respond back with a greeting to that name. For example, if the event had the name as Donald, our Lambda function will respond with "Hello Donald." Then to make our Lambda function capable of communicating debug messages, we have to require the SLAppForge Lambda Debug Proxy npm module from our function. We should add this require line at the very end of the file that contains the Lambda handler. Now we have two options to provide this dependency to our Lambda. The first one is to install this module as a dependency of this project itself. In that case, this module will be bundled into our project code artifact. On the other hand, SLAppForge has published a pre-built Lambda layer that contains this module. So the second option is to use that layer in the Lambda configuration. Let's go for the second approach, as it is easier and cleaner. So now we are done with implementing the code for our Lambda function. Let's bundle this into a zip file, so we can later upload it to our Lambda function. Let's now go to the AWS Lambda console, and create a new Node.js-based Lambda function. Then we can upload the zip file with our code to this Lambda function. Then we have to add SLAppForge Lambda Debug layer to our Lambda function. For that, click on this Layers button here, and then click on Add a Layer button. Now we can choose to provide a layer version ARN, and provide the ARN for the SLAppForge Lambda Debug layer. We can now save the changes. But before going further, let's create a test event and verify that our Lambda works as expected. We can now see that it has completed successfully within a few milliseconds. Before going to the next configuration step, we need to get a SLAppForge access key and a secret. For that, let's open the SLAppForge access key manager and log in. You can use your SLAppForge Sigma account credentials for this. If you don't have an account, you can go to the Sigma console and create a new account for free. Once logged in, we can click on this button here to generate a new access key and a secret. Then both of those can be copied to be used in later steps. Our next step is to configure debug parameters to the Lambda function. For that, let's go back to the Lambda console. Here we have to configure 4 environment variables to use debugging with this Lambda function. The first one of those is SLAppDebugger active variable. This is the flag that indicates whether the Lambda should be invoked in debug mode or not. We can set this to true to enable debugging. And once we are done with debugging, we can set it back to false. The second and third variables are SLAppKey and SLAppSecret. We have to set the access key and the access secret we generated earlier to these variables. The fourth one is SLAppSession variable. This value is used as a unique ID to distinguish this Lambda function for the debugger to connect. This can be any string value. But we must make sure to use the same value when we configure the local client later. Secondly, we have to increase the timeout of the Lambda function, to allow enough time for the debugging before the Lambda runs out of time. At present we can increase the timeout of a Lambda function up to 15 minutes. But generally we don't need a debug session as long as that. Hence, somewhere between 2 to 5 minutes should be generally adequate for most scenarios. Finally, let's save the changes and move on to the next step. Since we have completed the Lambda side configurations, let's move into the configurations to be done on our developer machine. As the first step, we need to install the SLAppForge local debug client in our machine. This is a Node.js command line tool, which is available in the npm repository. We should install it as a global npm module as this. Once installed, we can run it from our command line or terminal as follows, providing 3 required parameters. The first parameter is the access key we generated, and the second parameter is the access secret. The third parameter is the debugger session ID, which we configured on the Lambda side as an environment variable. Then the debug client gets started and waits for an IDE debugger to be connected. The same local client session can be used for multiple debugging sessions for the same Lambda function. Therefore we can start this once and keep it running. The next step is to create a debug configuration in the IDE. We are going to use JetBrains WebStorm IDE here, but the steps will be the same for the IntelliJ IDE as well. While in the project containing our Lambda code, click on the Add Configuration button on the top toolbar. On the Debug Configurations window, click the plus button on the top left, and select Attach to Node.js/Chrome. Provide any name for the configuration, and set the host as localhost, and the port as 9249. Keep the attach to type as Chrome or Node.js started with inspect. Finally, save the configuration by clicking the OK button. Now we have completed all the configurations and ready to run our debug session. As the first step, we have to invoke our Lambda function. We can do it either using a test event from the AWS console, or if you have set any triggers such as an API gateway or an S3 event, one of those also can be used. Now we can see that our Lambda function does not complete its processing within a few milliseconds as we saw earlier. Instead, it connects to the debug server and waits for an IDE debugger to be connected. If we do not connect an IDE at this stage, Lambda function will wait until the configured timeout passes without completing. So without keeping the Lambda waiting, let's go back to our IDE to start the debugger. Keep in mind that we should have our local client running for this to work. Also, we have to make sure that we add at least one breakpoint to our code before we start the debugger. If we start the debugger without any breakpoints, Lambda execution will be completed as soon as the IDE debugger is connected. Once the debugger is started, we have to wait for a couple of seconds until the connections are established and initial messages are exchanged. Then we can see that our breakpoint getting hit and the Lambda execution will be suspended at that point. Now we can debug our Lambda code similar to a usual remote Node.js process. Once the debugging is completed, Lambda execution will be completed as usual.